Breaking news! The problem that our team is proposing to address is the issue with abnormal gait mechanics and reduced walking efficiency when it comes to current prosthetic devices. This problem should be investigated majorly through patient feedback as opposed to computer-modeled simulations. The first task to investigate is simple and level ground, such as a treadmill. We would compare the oxygen consumption of each patient based on the different prosthetics used, similar to other research where they compare the current market prosthetics to a novel bionic foot, where the results concluded that the new bionic foot, which contains a spring that can be locked and unlocked to act as a suspension device, was vastly improved for those with transtibial amputation, but actually served no quantifiable benefit to those with transfemoral amputation. Research from Etundi can further expand the idea of these experiments, working to understand loading limitations and cyclical external forces on the devices in order to determine the long-term working conditions. Though not mentioned in the paper, the largest difficulty of rig testing is the validation. In order to determine if the modeling of the complex movements is accurate, there must be some comparison to the real long-term use of the device in vivo. Regarding the use of computer models and simulations, the framework provided by PROST defines error models from the use of in vivo testing and can apply them to new prosthetic devices before implantation. Using the model prosthetic created through error estimation, there was an improvement in propulsion and speed through the gait cycle, reducing effort and long-term injury in the user. The significance of these evaluations allow amputees to return to a comfortable gait and speed in their movement faster through improved testing, though more research could be conducted in similar mechanical replication for different amputation locations. Furthering this research could include the investigation on prosthetics on more difficult terrain and how more support could be offered to the user in regards to balance and stability as opposed to solely efficiency. McDonald experimented with the addition of a passive toe joint for better grip on more challenging surfaces. Error comes out in the subject-specific research, though, with only a slight majority claiming to prefer the additional joint, despite a reduction in work on the hip joint across the board of users. Teeter conducted a similar experiment on passive toe joints to increase the ease of incline and decline walking on the user. Similarly, few actually preferred the addition of the toe joint, despite the decrease in work for both incline and decline walking, though it was measured to only be a reduction worth a few joules.